Hello, we're going to discuss the second example of this section um, and work through it in more detail. So this section is about differentials. The differential is defined as the derivative times dx. Okay, it's not the derivative, so make sure you know the difference. And the reason why we talk about differentials is because a lot of times we can use differentials to estimate the change of a function. Okay, let's just do an application problem by using differentials. It says in this example, the relationship between the amount of money expended by Canon precision instruments advertising in the Canon's total sales S of X is given by the function. So this function S is total sales, the number of sales. And X is the, the money spent. Okay, so this tells how much sales, you get when you spend the X amount of money. So where X is between 0 and 200 in $1,000. So X is measured in thousands of dollars. All right. So when you spend some money, you get increase in the sales. Okay. So how much is the sales when X is 100, for example, if you put $100,000 in advertisement, what would be the sales? All right. So the question is, use differentials to estimate the change in Canon's total sales. If advertising expenditures are increased from 100,000 to $105,000. Okay. So namely from X equal to 100 to X equal to 105 in the units of $1,000. So this question just asks you, the effect of advertising, how much you spend in advertising will result in the increase of the sales. Okay, so we need to know, how effective is advertising in this case. So basically, if we translate the problem in mathematical language, the sales, it says, what is change of this S when X is increased from 100 to 105? Okay, so we are trying to find the change of the function by a small change of the variable X. In this case, we can use differentials to estimate this change of S. So how do we do that? Let's try to find the differential first. So in order to find the differential, we need to find the derivative. Okay, so let's just start from the formula of the differential. Okay, so ds, that's the notation for the differential, is defined as the derivative of the function s prime of x times the increment in x. Okay, so we can use delta delta x to denote this increment in x. So that's just definition of the differential of s. Now, we can easily find the derivative of this function s. So let's just do it term by term. I guess we have done this many times. So I'm not going to write down all the details. So when you take the derivative of the first term, you just take the derivative x cubed times the negative 0.002. But the derivative of x cubed is just the 3x squared if you use the power rule, right? So the derivative of x to n is n times x and to the n minus 1, so n equals 3. So we got 3 times x to the 3 minus 1, so 3 minus 1 is 2, so that's 3x squared. That's first term, and the second term basically you do the same thing. So you got 6.6 times derivative of x squared, and you already know that. Using the power again, so we got n times x to the n minus 1, and it's 2, so we get a 2 times x to the 2 minus 1, 2 minus 1, which is 1. So we got x to the 1, but x to the 1 is just x, so the second term is just 2x. And the derivative of x is just 1, okay. And the derivative of 500 is 0 because it's constant. So at the end, so that's just the derivative. Okay, so we have to multiply the whole thing with the the increment in x. Okay, I'm sorry, I forget that. Okay, so that's the derivative of the function. We still need to multiply increment in x. So, okay, that's right. So let's just simplify this a little bit. So 0.02 times 3 is just 0.06. So that's negative 0.06 x squared. First term. And then we got 6.2 times 2. So that's 1.2 times x in the second term. Sorry about it. And then plus 1 at the end. And that's the derivative. So we need to multiply the increment in x. All right. So that's the differential. Now we are asked to find to estimate the change in Canon's total sales. And we use differential ds to approximate it. Okay, so what's the connection here? So the increment in S, we use delta S, or the change in Canon's total sales. So that's the change of the function S. We use delta S to denote it, and we can use the differential to approximate it. Okay, so that's the formula here. We use the differential in S to estimate the change in S. All right. Now the only thing left is just plug in numbers. In here, we got x from 100 to 105, so we can easily find out what delta x is. Namely, you just take the difference between 105 and 100. So that's just 5. Okay. So that's the increment in x, the change in x in this problem. Okay, that we're going to use to plug into the formula for the differential. And the other thing we need is x, and we know this time we're going to use 100. So that's where you start. Okay, you start from 100 and increase to 105. So x is 100, and the increment in x or change in x is 5. So just plug in 100 for x and 5 for that x. Then we got the numerical value of the differential. So we can calculate the value of ds. So just plug in those numbers in the formula. So what is x? So that's 100, isn't it? So just plug, oh wait. Just plug in everything. I'll plug in 100 everywhere in here. Why do I always make this kind of mistake? Okay, so that's x, and then delta x is just 5. Okay, so multiply 5 at the end. So the next thing is just figure out the number. Okay, so 100 squared is 10,000, isn't it? So that's 0.0006 times 1,000 or 10,000. Okay, plus 1.2 times 100, so that's 120 and plus 1. All right. Now, let's just figure out the number. Negative 0.06 times 10,000, that will be negative 60, I believe, if I'm right. Yes. Okay. So negative 60 plus 120 plus 5 times 5. All right. So what will be the answer? Okay. So that's negative 60 plus 120, that's positive 60. And 60 plus 5 is 65. Times 5. The answer will be what? 325, isn't it? Okay. Let me double check it. Okay, that's right. 305. Let's see, what did I do wrong here? I think it is 325 instead of, oh wait, no. Plus 1, I'm sorry, that's why I did it wrong. So that's 61. Negative 6 plus 20 is 60 plus 1, 61 times 5. So that's 305. So so data is approximately equal to ds, and that's just a 305. Okay, so but this 305, is just the total sales. Okay. And it's in $1,000. So if you put 5,000 more from $100,000 in advertisement, you're going to get a revenue increase of $3,000 or $5,000. All right.